Hello musicians, welcome back. My name is Bucky Dirtle and I'm doing another video tutorial on the VCV Rack modular synthesis DAW. And today I'm doing a tutorial on the Riemann chord generator. Now this is the first of a series on this module, because this is a very complicated module. So I'm going to try to cover off a few things in this tutorial, and I will move on to some other things in another one. I'm trying to keep things as straightforward as I can, because this is quite a complicated module. Today I'm going to be talking about how this actually works, and then we'll talk about other aspects of it in future tutorials. Before we get started, let's have a look at what my setup is here. Now I'm using the newest version of VCV Rack. It's version 0.6.0. And so at the time of shooting this, that's the most latest version. It just came out a few days ago. So there are some changes. For example, you can see here in my audio interface, right here, you'll see that this is a change to what it was before. So there are some changes here and there. You'll notice how it manages plugins is different as well, but we might get into that in another tutorial. But right now we're just going to talk about the Riemann module. Now you'll notice I have a 8-channel mixer here. This is AS module. It's 8-channel mixer, nice mixer. Down at the bottom you'll see you have a whole slew of VCV1s. Now I could probably use other, maybe slimmer VCOs, but I wanted to use something that's very simple, straightforward, so everybody will be able to see how it works, and everybody would have the same modules on your machine. So I'm using that very simple module, that simple VCO. Now up at the top left you'll notice I have the Lisa U LFO, which I love, by Frozen Wasteland. I'm not going to be using that in this tutorial, but I am going to use it in future ones. I'm going to leave it here, but we are going to use it in future tutorials. In this one today we're going to be looking at LFO1 and LFO1. We have here two LFO1s, which are from the fundamental pack as well. Now we have Riemann chord generator. Let's have a look at what we have here. So let's just look at the layout first of all. You'll notice that there's some action happening up here on this display, and we have a whole load of notes here. We can see A, E, B, F sharp, and we have all these other ones along in here on the inside. I'm not going to get into a theory lesson today on this, but what I will say is that when you go around the circle this way, we're moving in fifths. Okay, you see that's fifths around. So the distance between C to G is a fifth, from G to D is a fifth, from D to A is a fifth. So there's fifth, 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 all the way around the circle of fifths. And then on the inside ring here, second one, same deal. You can see that we have fifths with C to G, G to D, D to A. This is another row of fifths on the inside, and a third row of fifths, and a fourth row of fifths. So the circles are fifths. Now, if we go from, like if we step in this way, from this C to an E, well, that's a third, a major third. And then E to G sharp is a major third. You see that? And then we can go from here, F to A is a major third. A to C sharp, major third. So we're moving thirds as we go in. You see these arcs that go in, these are thirds. Now, and these are all the way around. They're thirds as you move into these arcs toward the center of the circle or out. It's all a major third. Now, that's important. When you look down here, we have a perfect fifth right here. You see, we have perfect fifth, and we have a major third right here, these two inputs. So we'll talk a little bit about what these mean in a minute, but those are two inputs, and they are thirds and fifths. Okay, now I want to talk about the sound. How do we output sound here? Let me just zoom out a little bit. Now remember we have all of our VCO ones along the bottom here. Now they're all tied into these outputs all along here. Now again, I'm not going to go to a music lesson, but a chord would comprise of a root note in the chord, or whatever the bottom note of the chord would be. Well, I'll say root. And again, I don't want to get into a music lesson, but the root of the chord. Then it would be a third, and then a fifth, and then if you want to, a seventh, a ninth, 11th, and 13th. So that's if you were spelling a typical chord. That's what it would be. Now, if that was it was just in root position, okay, no inversions, it would be first, third, fifth, seventh, ninth, 11th, and 13th chord. 13th. No, so these are the intervals. Now, what we have here is the Riemann chord generator will output the tones for each of these intervals. So it'll output the first degree of the root of the chord right here. So let's say if you were playing a C chord, that note right here will be a C. If you were playing a C chord, that note here will be an E and a G, and go on like that, the 7th, the 9th, the 13th, 11th, and 13th. So what it does is it outputs the control voltage, the voltage, sorry, not control voltage, but voltage level for each one of these as a separate output. So it's not outputting the chord as like one tone, because you can't really do that. What it's doing is it's sending out the voltage that will then go into a VCO, into the voltage per octave, and then that can be outputted from the VCO. So let me just show you a chain of events here. I'll take this blue one here. See, it's on the root. So if I connect it to the root, it goes out of here and it's going into this VCO right here. This is this one right here. It's going into voltage per octave. I'm going to scroll down a little peck so you can see a little better. And then the sine wave, I have a sine wave coming out of that VCO, and it's going up to my input number 2 on my mixer right here. You can see the red channel right here. So what the Riemann is doing is it's saying when it decides on a chord it's going to play, let's say C for example, that root of the chord, 1, which is right here, that root will be the control voltage, or the voltage level for that root will go out to the VCO as a voltage per octave into the input for voltage per octave. That VCO will then output the proper frequency as whatever waveform I want to choose. I mean, I could choose triangle, saw, whatever I want, but I'm going to choose sine wave, and that will come out and go as a sound, as a frequency, and that will go to my mixer and then go out as a sound. So the third degree of the scale, which is the green guy right here, this green one, the third degree of the scale will also go out and go into the next VCO, and that will be outputted back into channel 3 of my mixer. The 5th degree of the scale will be outputted to this VCO right here, and again go out to the mixer, and the next, and the next, and the next. So it can, in fact, create an 7-note chord, a 7-note chord. Now you're saying you got 8 outputs. Okay, I'll get to that in a minute. Let's just forget about that for a second, because there are 8 outputs, but see the T? Leave the T for now. So the 1st degree of the chord, 3rd degree, 5th, 7th, 9th, 11th, and 13th will all have its own oscillator, and each one of those oscillators can be fine-tuned in whatever way you want. You can detune them, you can make one a square wave, pulse width, you can make one a triangle, whatever. You can fine-tune them whatever way you want. So that is that. Now, the T is tonic. So in this chord generator, you can say, okay, we're going to be playing in the key of C. So no matter what chords are played, you can play a G chord, a D chord, an F chord, whatever chord you want, it'll always play the tonic. And that's this guy right here, the tonic. So if you're in the key of C, tonic of C is C. Tonic of A is A. Okay, so, but if you're in the key of C and it's generating chords in that scale, that key of C, then it'll always output that tonic, and that won't change. So that's over here on this on the first of my VCOs. So, and that goes up to number 1 here. That's right here, the first input on my my mixer. Okay, so that's that. That's all of the outputs across here. Okay, so now you know how the sound is coming out of it. Let's have a look at how the sound goes into it. I'm going to disconnect this guy right now. Actually, I'm going to leave that guy. No, I'm going to disconnect that guy. I'm going to start with the thirds. Now, I said before that on our rings here on our display, actually, I'm going to zoom in so you can see it nice and clear. I'm going to zoom way in here. There we go. That's better. So you'll see here that the I'm connected a sine wave. Actually, you know what? I'm going to connect a triangle wave. And remember now, triangle wave will ramp up a triangle wave and it'll ramp down a triangle wave at the same speed. It won't gradually come to a stop and gradually go in the other direction. No, it's the same direction as it moves through its frequencies. So you'll see here this ball is moving back and forth, and this is frequency. It's reading the frequency from the LFO, and that's the speed it's moving. And see, it just changed direction. So it reached the top of its crest and started going down, or vice versa. Now, what this input right here, this means is that the control voltage that's coming from the LFO is making the chord generator move on this little arc. Okay, it's moving in a third. Okay, these are thirds. So sliding back and forth across the thirds. Now it's not jumping from A to C sharp to F. No, it's moving gradually through these. And as it moves through this arc, the chord generator is deciding, yeah, that's close enough to an F. We'll start playing an F. That's close enough to a C sharp. Yeah, we'll start playing a C sharp. So it doesn't do it. It doesn't do it like, it doesn't pop to the chords. It does it in a gradual sort of way. Let's turn up our volume and have a listen to what we're actually hearing here. Okay, that's the little volume. So you can hear the chords changing gradually, and I have this moving along really slowly. Now, if I was to turn my speed up, my frequency up, you'll see it moves very quickly back and forth. But I'm going to slow it down so it's nice and it's more musical, because chord changing generally doesn't change very fast in music. So it's nice and slow. So that is a major third. It's moving as a major third. Now I'm going to slide over a little bit. I'm going to connect the perfect fifth. Actually, let me disconnect a third first. I'm going to connect the perfect fifth. I'm going to connect it to this guy over here. Now you'll see, remember I told you that the rings, as they go around a circle, those are fifths. So this control here, the perfect fifth control, is the control that will make it move in circles around the circle, and will go into one direction, and when it reaches the end of its, like the top of its negative or top of its positive part of the cycle, or its bottom of its negative of the cycle, it will change direction. And this is a triangle wave. If I had it as a saw, it would behave as a saw wave, or a sine wave, or a square, whatever. Okay, so now you can see it's moving back and forth on this plane. Now what happens if I run both at the same time? Let's take my triangle wave and connect it to the major third. And you'll see now it's going to be a combination of both. And as it moves outside the ring, it will go in the other direction. You see, it'll come in from the other side. But when it passes over, see, it comes in again. And you can hear the chords changing as it's doing that. It's changing across the chords. Now, what we have right now, I'm not going to talk to you about what chords are actually being played here, because that's going to be in another tutorial. But you can see as the ball falls into certain quadrants, it changes chords based on what notes are adjacent to those quadrants. So I'm saying quadrants. I don't know if it would be maybe quadrant might not be the right word, because there are triangles, I'm not sure. But either way, when it goes into the range of a certain number of chords, it will do that. And you can see here that we have circles. See, the circle shows up, it's an E circle. See the F? That tells us what our chord is based on, the root of the chord. So it changes chords as the ball moves around. So you can see that. Now if I change it to a sine wave, the manner to which that they change will be different. There will be much more curves to it, and the ball will slowly move around and more really organic, as you have, because you have two LFOs affecting that ball, and as it moves around. So that's how it controls the chords. So in this tutorial today, I wanted to show you all of the outputs and the inputs of this chord generator. Now we haven't gotten into the chord selections, haven't gotten into the voicings, the parts, transposition, any of the control voltages, and we haven't gotten into how we can play with it with some funky LFO controls. But we will get into that in another tutorial or two. Okay, so there you go. That's a Riemann chord generator. Now that's by South Pole. As I say with all these tutorials, if you enjoy these tutorials and you enjoy these pieces of software, be sure to go to the developer's website and show your support for the developer, because they work really hard and they are open source projects, so you need to go and show your support for these people. Okay, thank you very much for watching, and I will see you next time.